Lesson 14 is on combining like terms, and I have decided to break it up into two sections. Today we will be looking at problems that do not include the distributive property, and then tomorrow we will include the distributive property. So when we're combining like terms, we need to know what a term is, and that is a number or a variable or a product or quotient of numbers or variables that is added or subtracted in an algebraic expression. So underneath here I have there are four terms in the following expression. So looking at this, there's four terms. This is a term, this is a term, this is a term, and this is a term. So notice I am including that positive plus sign or that negative sign with each term. I also sometimes refer to those as chunks. That seems to help some kids understand terms a little bit better. So if you divided that up into chunks, that's what you would have. That sign in front of their number is very important when we're combining like terms, and I'll show you why in a second. This first one, 2x, doesn't have a sign out front, so that means it's positive. So whatever your first term is, if there's not a negative sign out there, it is positive. If it was negative, it would already have the negative sign there. So that one is definitely positive. Okay, a variable is a symbol, usually a letter, used to represent a quantity that can change. So we've been working with variables for quite some time now. We usually use X, Y, Z, M, T, H, anything like that. It can be a symbol, but we normally don't use those. We stick to the letters. Coefficient is the number that is multiplied by a variable. So in this term 2x, so we're looking at 2x, 2 is the coefficient. It's the number being multiplied by the variable. So that when you hear the word coefficient, we're just talking about the number out front that's being multiplied by that x. This one is important here in the term x. So if you just have an x, maybe a y or a z or whatever letter, if it's just an x with no number in front, no coefficient, that means it's 1. That is a 1x. So we don't write that, but you need to remember that it is a 1 because it's going to be very helpful to you. Constant is a term in an algebraic expression that does not change. That means it does not include a variable. So in this expression, x plus 2, 2 is the constant because it's always going to be plus 2. It stays plus 2. We can plug any number we want in for x, but we're always going to have that plus 2, that positive 2 at the end. So that's our constant. It stays the same. So now we have like terms. So these are very, very important to us in how we're going to do our work today. Like terms are terms that have the same variable raised to the same power. So I have a few different examples here. For part A, 2 and 3 are like terms. They're both just constants. They're both numbers. So we could combine them. We could add them if they're both positive. 2 and 3 look like they're both positive to me. So 2 plus 3 is 5. So I can combine those. For part B, we have 3x and 2x. They are like terms as well. They have the same variable. So we could combine those. If I wanted to add those, I would have 3x plus 2x. That would mean I'd have 5x's. So just think about that variable being like apples or oranges. If I have 3 apples and 2 more apples, then I have a total of 5 apples. Well, they're not really apples in this case, they're x's. C, 3x and 2y are not like terms because they have different variables. One's an x and one is a y. Therefore, I cannot combine those. Those do not get put together. D is 3ab and 2ab, and those are like terms because they are the same variables. Even though there's 2 of them, they both have ab. So those could be combined as well. E, 3x and 3x squared are not like terms. They both have an x, but they don't have the same exponent. So This one has a squared. This one is really just a 1. We don't write that one up there, but that is a 1 and that one is a 2, and that's not the same. So we cannot combine anything that looks like that. And then F, we have 3xy and 2yx. Those are like terms as well because it's being multiplied, and we can multiply in any order. 3 times 5 is the same thing as 5 times 3. So x times y and y times x, they are the exact same thing as well. So I could combine these. All right. Addition and subtraction, only like terms can be combined. So if it's just adding and subtracting in our problem, we can only combine things that are exactly the same. So exactly the same letter and exactly the same exponent. So for examples here, I have 3x plus 2x. They have the same letter and their exponents are both 1. They're not written, but that's what they are. So I can go ahead and combine these. I can do 3x plus 2x. And 3 plus 2 is 5. And we have 5 x's. So if you thought about it, here is 3 x's, and then I'm going to add 2 more x's to my group. So how many x's do I have in total? I have 5 x's. This one, I have 3x plus 2y. Notice the variables are not the same. So when I'm asked to combine like terms, I can write can't combine. All right, and then we get this larger problem. So I'm going to start with the first thing. I have a 3x. I'm going to go through and look for any more x's. I see this positive 2x. So I can combine those. 3x plus 2x is 5x. Then I'm going to go to the next number. I have this positive 10. That's a constant. So I'm going to look. Do I have any more constants? I have this positive 13. So 10 and 13 make 23, positive 23, so that's why I put plus 23. And then next here in my line, I have this positive 3y. So I'm going to look, and here's another y. So I have 3y minus 2y. So if I have 3 minus 2, that's 1. So I have a positive 1y. So I'm just going to write y. We don't write the 1 in front of it. And then that is our simplified answer. We have combined like terms. All right, for this one, the first term is 3x, and I'm going to look for another x, which I see one here. So I have 3x minus, remember that's a 1, so 3 minus 1 is 2 with our x. So we have 2 x's, and then I have this positive 8 here. It doesn't have anything else. There's no other constants. There's nothing else. So I'm just going to write plus 8. So 2x plus 8 is my simplified version of that problem. All right, and then this one, I start with an x, so I'm looking for an x. Any more x's? I see positive 4x. So 1x plus 4x gives me 5x. And then I have this positive 1, that's a constant, so I'm looking for another constant. There's a plus 4, so 1 and 4 make 5, positive 5. And then I have this x squared, this positive x squared, and it's the last term. There's no other terms to combine it with, so I'm going to put plus x squared. So that is my simplified version of that problem. I want you to notice how I underlined like terms, I circled like terms, and then I used triangles for like terms. That might be something that helps you out while you're doing your assignment. Also, you can see that I've used different colors. So if you have highlighters, if you're working on a piece of paper, you can use highlighters, or if you have different colored pens or colored pencils, that sort of thing, it might help you see the like terms a little bit better and be able to combine them a little bit. And then once you get doing this, you probably can steer away from having the circles and the triangles and all that stuff in the different colors. But as we're just starting out with combining like terms, it might be pretty helpful to you.